National Electrical Code Section 430.10. These states control equipment shall be mounted in a readily accessible location and shall be provided with nameplates indicating the purpose of the equipment and the load it controls. This code section requires control equipment to be mounted in a location that allows for easy access and identification. The National Electrical Code does not specifically prohibit mounting control devices on the inside panel of an enclosure, provided that the following conditions are met. Firstly, the location is readily accessible, allowing for convenient maintenance and troubleshooting. Secondly, the controlled devices are clearly visible and labeled with their purpose, as required by Section 430.10. B. When considering the placement of control devices, safety should be paramount. The location of the control devices should not pose a safety hazard to personnel. Electrical panels should be adequately sized and ventilated to prevent overheating and electrical hazards. From a maintenance perspective, technicians should have sufficient space to work on the control devices safely and efficiently. While the National Electrical Code does not have specific aesthetic requirements, it may be preferable to mount control devices on the back plane of the enclosure for a more professional and organized appearance. Therefore, based on the National Electrical Code, the installation of controlled devices on the inside panel of the starter cabinet is not inherently prohibited, provided that the location meets the requirements for ready accessibility and proper labeling. However, it is recommended to consider the additional safety, maintenance, and aesthetic factors when making this decision. Accessibility is a critical aspect of electrical installations, ensuring that qualified personnel can safely and easily reach components for inspection, maintenance, and repair. The National Electrical Code mandates specific requirements for accessibility to prevent hazards and facilitate efficient operations. Readily accessible locations are defined as sites that are directly reachable without requiring tools, ladders, or the removal of obstacles. This is particularly important for control equipment, which may need frequent adjustments or troubleshooting. Ensuring that control panels and devices are readily accessible minimizes downtime and enhances safety for technicians. Obstacles such as fixed structures, stored materials, or inadequate lighting can impede access and create hazardous working conditions. Clear pathways, sufficient workspace, and proper illumination are essential for maintaining accessibility. Regular inspections should be conducted to identify and remove any obstructions that may hinder access to electrical equipment. Proper labeling of control equipment is another key component of electrical safety in compliance with the National Electrical Code. Nameplates should clearly indicate the purpose of each device and the load it controls, enabling quick identification and preventing errors during maintenance or emergency situations. Labels must be durable and resistant to environmental factors such as moisture, heat, and abrasion to ensure long-term legibility. Standardized labeling practices promote consistency and reduce the risk of misidentification, which can lead to dangerous situations. In addition to nameplates, color coding and visual indicators can further enhance the clarity of labeling systems. Safety is of utmost importance when dealing with electrical installations. Electrical panels should be adequately sized and ventilated to prevent overheating and potential electrical hazards. Overcrowded panels can restrict airflow, leading to increased temperatures that degrade components and increase the risk of fires. Proper ventilation helps dissipate heat, maintaining optimal operating conditions and extending the lifespan of equipment. Regular inspections should include thermal imaging to identify hotspots and potential overheating issues. Safety protocols should be strictly enforced to prevent electrical shocks and arc flash incidents. Qualified personnel should always use appropriate personal protective equipment, including gloves, eye protection, and flame-resistant clothing, when working on electrical systems. Lockout-tagout procedures should be implemented to energize equipment before maintenance or repairs are performed, ensuring that circuits are not accidentally energized while work is underway. Maintenance is an essential aspect of ensuring the reliable and safe operation of electrical systems. Regular inspections, testing, and cleaning can prevent failures and extend the lifespan of equipment. Technicians should have sufficient space to work on controlled devices safely and efficiently, minimizing the risk of accidents and ensuring thorough maintenance. Adequate workspace allows for the use of tools, diagnostic equipment, and replacement parts without obstruction. Maintenance activities should be documented, including the date, time, and specific tasks performed. This information can be used to track trends, identify recurring issues, and plan future maintenance activities. Preventive maintenance programs such as tightening connections, replacing worn components, and calibrating sensors can significantly reduce the likelihood of unexpected breakdowns. While the National Electrical Code does not have specific aesthetic requirements, the appearance of electrical installations can reflect the overall quality and professionalism of the work. Mounting control devices on the back plane of the enclosure can create a more organized and visually appealing layout. Neat wiring, consistent labeling, and clean surfaces contribute to a professional appearance. Aesthetic considerations should not compromise safety or functionality. All installations must comply with the National Electrical Code and other applicable standards regardless of their appearance. Regular cleaning and maintenance can help maintain the aesthetic quality of electrical installations over time. The National Electrical Code provides a comprehensive set of guidelines for electrical installations, covering various aspects such as wiring, grounding, overcurrent protection, and equipment installation. Compliance with the National Electrical Code is essential for ensuring the safety of people and property. Local authorities having jurisdiction may have additional requirements that must be followed. Staying up to date with the latest National Electrical Code revisions is important for electrical contractors and engineers. Continuing education courses and industry publications can help professionals stay informed about changes in the code and best practices for electrical installations. The National Electrical Code is a living document that is updated regularly to reflect advancements in technology and address emerging safety concerns. Understanding the National Electrical Code and applying its principles is crucial for designing, installing, and maintaining safe and reliable electrical systems. Proper installation and maintenance of electrical equipment not only ensures safety but also contributes to the efficient operation of facilities and reduces the risk of costly downtime. By adhering to the National Electrical Code and best practices, electrical professionals can create environments that are both safe and productive. The location of control devices within an electrical panel can significantly impact the ease of access and overall safety of maintenance operations. Positioning components in a manner that requires technicians to strain, reach, or contort their bodies can increase the risk of injury and reduce the efficiency of work. Ideally, control devices should be mounted at a comfortable height and within easy reach to minimize physical strain. Proper ergonomics in electrical panel design can improve worker safety and productivity. The layout of components should be carefully planned to avoid overcrowding and ensure sufficient space for hands and tools. Clear pathways for cable routing can prevent tangling and make it easier to trace circuits. Color coding of wires and components can aid in identification and reduce the risk of errors during maintenance or troubleshooting. In addition to physical accessibility, the clarity of labeling and documentation plays a crucial role in facilitating efficient maintenance. Detailed wiring diagrams, component lists, and troubleshooting guides should be readily available to technicians. These resources can save time and reduce the likelihood of mistakes when diagnosing and repairing electrical problems. Electronic documentation systems can provide quick access to information and allow for remote troubleshooting. Proper training of personnel is essential for ensuring that they are competent in performing maintenance tasks safely and effectively. Training programs should cover topics such as electrical safety, lockout-tagout procedures, troubleshooting techniques, and the proper use of tools and equipment. Regular refresher courses can help reinforce knowledge and keep technicians up to date with the latest industry practices. A well-trained workforce is better equipped to identify potential hazards and prevent accidents. The selection of appropriate enclosures for electrical equipment is critical for protecting components from environmental factors and ensuring the safety of personnel. Enclosures should be rated to withstand the conditions in which they will be used, such as moisture, dust, temperature extremes, and corrosive substances. Proper sealing and gasketing can prevent the ingress of contaminants that could damage electrical components. Ventilation openings should be designed to allow for adequate airflow while preventing the entry of foreign objects. Grounding and bonding of electrical equipment are essential for providing a safe path for fault currents and preventing electrical shocks. All metal enclosures and conductive parts should be properly grounded to the built-in grounding system. Bonding jumpers should be used to connect separate metal parts to ensure electrical continuity. Regular inspections should be conducted to verify the integrity of grounding and bonding connections. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating or damage. These devices should be properly sized and installed to provide adequate protection. Regular testing should be performed to verify that overcurrent protection devices are functioning correctly. Coordination studies should be conducted to ensure that overcurrent protection devices trip in the correct sequence to minimize the extent of outages. Surge protection devices are used to protect electrical equipment from transient voltage surges caused by lightning strikes or other disturbances. These devices should be installed at the service entrance and at sensitive equipment locations. Regular inspections should be conducted to verify that surge protection devices are functioning correctly. Proper maintenance of surge protection devices can prevent costly damage to electrical equipment. Power quality monitoring is a valuable tool for identifying and addressing electrical problems that could affect the performance and reliability of equipment. Power quality analyzers can measure voltage, current, frequency, harmonics, and other parameters. The data collected can be used to diagnose issues such as voltage sags, voltage swells, and harmonic distortion. Addressing power quality problems can improve the efficiency and extend the lifespan of electrical equipment. Energy efficiency is an important consideration in the design and operation of electrical systems. Energy-efficient equipment, such as LED lighting and variable frequency drives, can reduce energy consumption and lower operating costs. Regular energy audits can identify opportunities to improve energy efficiency. Implementing energy management strategies, such as demand response programs and peak shaving, can further reduce energy costs. Renewable energy sources, such as solar and wind power, can provide a clean and sustainable source of electricity. Integrating renewable energy sources into electrical systems requires careful planning and coordination. Grid interconnection standards must be followed to ensure the safety and reliability of the electrical grid. The use of smart grid technologies can improve the efficiency and reliability of electrical systems. Smart meters can provide real-time data on energy consumption, allowing consumers to make informed decisions about their energy use. Automated grid management systems can optimize the flow of electricity and prevent outages. The integration of distributed generation sources, such as rooftop solar panels, can create a more resilient and decentralized electrical grid. Electrical safety is a shared responsibility that requires the cooperation of all stakeholders, including electrical contractors, engineers, building owners, and occupants. By following the National Electrical Code and best practices, we can create electrical systems that are safe, reliable, and efficient. Continuous improvement and innovation are essential for advancing the state of electrical technology and ensuring a safe and sustainable future. The accessibility of control equipment is not only a matter of code compliance but also a practical consideration that impacts the efficiency and safety of operations. When control devices are located in hard-to-reach places, technicians may be tempted to take shortcuts or use improper tools, increasing the risk of accidents. Ensuring that control equipment is readily accessible promotes a culture of safety and encourages technicians to follow proper procedures. Accessibility also facilitates routine inspections and preventive maintenance, allowing potential problems to be identified and addressed before they escalate into major failures. This can reduce downtime, minimize repair costs, and extend the lifespan of equipment. In addition to physical accessibility, the design of control panels should consider the cognitive accessibility of information. Clear and concise labeling, intuitive layouts, and standardized symbols can help technicians quickly understand the function of each control device. The use of color coding can further enhance the clarity of information and reduce the risk of errors. Well-designed control panels can improve the efficiency of troubleshooting and reduce the cognitive load on technicians. The National Electrical Code provides a framework for ensuring the safety and reliability of electrical installations, but it is not a substitute for sound engineering judgment. Electrical engineers should carefully consider the specific requirements of each installation and design systems that meet or exceed the minimum code requirements. They should also take into account factors such as the skill level of maintenance personnel, the environmental conditions, and the potential for future expansion. A holistic approach to electrical design can result in systems that are not only code compliant but also optimized for performance, safety, and maintainability. The selection of electrical equipment should be based on a careful evaluation of its performance characteristics, reliability, and suitability for the intended application. Equipment should be tested and certified by a recognized testing laboratory to ensure that it meets applicable safety standards. The use of high-quality equipment can reduce the risk of failures and extend the lifespan of electrical systems. Life cycle cost analysis can be used to compare the total cost of ownership of different equipment options, taking into account factors such as purchase price, installation costs, maintenance costs, and energy consumption. Sustainable design principles should be incorporated into electrical installations to minimize their environmental impact. This includes using energy-efficient equipment, reducing waste, and conserving resources. The use of renewable energy sources can further reduce the environmental footprint of electrical systems. Life cycle assessment can be used to evaluate the environmental impacts of different design options. The National Electrical Code is a dynamic document that is constantly evolving to reflect advancements in technology and address emerging safety concerns. Staying up to date with the latest code changes is essential for electrical professionals to ensure that their work is compliant and safe. Continuing education courses, industry publications, and online resources can help electrical professionals stay informed about the latest code developments. Active participation in code development committees can provide an opportunity to contribute to the evolution of the National Electrical Code. The goal of the National Electrical Code is to provide a set of minimum safety standards for electrical installations. However, it is important to recognize that the code is not a substitute for sound engineering judgment and good workmanship. The electrical professionals should strive to exceed the minimum code requirements and to create electrical systems that are safe, reliable, and efficient. The safety of electrical systems is paramount and should never be compromised for the sake of cost or convenience. By adhering to the National Electrical Code and best practices, electrical professionals can create environments that are safe and productive for all. Continuous learning and improvement are essential for advancing the state of electrical technology and ensuring a safe and sustainable future.